Hello everyone, my name is Danyal Reyaz and I'm presenting my project in the Young Scientist program where I calculated the complexity of different human languages. It is part of a bigger project where we use complexity theory and other statistical metrics to analyze various time series data. So I guess we can begin with what is complexity and why it is relevant. Complexity in the context of time series refers to the measure that can capture both the randomness and the underlying structure within the system. It is not simply entropy, but also about the pattern and correlations that can define the time series data. Understanding it can help us delve deeper into the system's underlying correlations and patterns and help us derive an understanding of its source of origin. Now, why languages? Languages form the basis of human communication. They have intricate structures, and statistical complexity can help us analyze this data. Uh, Languages are inherently complex systems rich in structure and intricate rules governing syntax, phonetics, and semantics. By analyzing their audio files, we can reveal unique linguistic patterns and possibly understand language evolution better. Coming to our methods, the most important part of any analysis is the data pre-processing. So for our purposes, we have prepared scripts which can convert the audio files into time series data by extracting and analyzing the key frequency components. This way we gain the most relevant information that is required for our time series analysis. The results of the pre-processing are shown alongside. So how do we calculate complexity? We have a code prepared in C++ that can calculate the complexity of any time series we feed into it. And this is the output and how it looks like. Similarly, we can talk about other relevant metrics that we calculate for our time series data, including elementary statistical measurements such as mean, deviation, kurtosis, etc. We also calculate zip compressibility and Shannon entropy, which can help us give insights into the repetitiveness of the data or perhaps the uncertainty or randomness present inside it. Coming to the results section, this is the statistical complexity of different human languages plotted in descending order. By looking at this data, we can perhaps group the languages based on geographical regions or linguistic families and such. Most European languages seem to have relatively high complexity, whereas Asian languages range from low to very high complexity. On the other hand, African languages seem to have lower to moderate complexity. We can also group them into linguistic families, such as Indo-European and Sino-Tibetan languages having generally high complexity, but Afro-Asiatic languages having moderate complexity. Most modern standard languages also seem to have moderate to high complexity, and less globalized languages seem to have lower complexity, which is opposite to what one might expect. Similarly, we have some elementary statistics. The coefficient of variation, standard deviation, and variance seem to be high in languages such as Tamil and French, indicating greater variability in the speech pattern. Uh, the compressibility ratio is high in languages such as Burmese and Portuguese, suggesting simpler structures. Moving on to some of the future directions where we can take the project in, we can extend the analysis to different languages which we have not already analyzed. It can help us gain a deeper understanding of the historical and cultural background of these languages. We can also use this to correlate linguistic features between various languages such as syntax and phonology, which might contribute to the complexity of the languages. Similarly, we can extend our analysis to the languages of other species, such as bird songs and whale sounds. And we can use our understanding to figure out what the complexity in other time series might mean. Uh, Thank you very much. That brings us to the end of my presentation.